Right, hello. Right, this one is going to be angles in 2D shapes. Um, Not circles. We're going to look at these sorts of things, which are rectangles and squares. So they have a collective name of quadrilaterals. So we've got rectangle, square, and we've got this one, a parallelogram. And of course we'll be looking at triangles of various different kinds. Right, okay. Now these are the internal angles. So first of all, we look at an equilateral triangle. Woo! An equilateral triangle. Yeah. Now this is where all three sides are the same and all three angles, with a little curvy bit there, all three angles are the same. Now the sum of angles in a triangle is 180 degrees. Yeah, means that you add them all up together and they will always be 180 degrees. Doesn't matter what kind of triangle it is. Now, if this is an equilateral triangle and all three angles are the same, and adding them all up together will be 180, we take the 180 and divide it by 3, which means that each angle is 60. So if you've been given the information that it is an equilateral triangle, you very quickly can find out or know what all the individual angles are. No problem whatsoever. Yeah. No problem whatsoever. Now, this one. This is an isosceles triangle. And this has two angles the same. And it happens to be down there. So these two are the same, and this little dash means these two sides are the same as well. So there's the sort of narrower, pointy bit, and these two are the same. And remember, all add to 180. No problem at all. Now, if we say that this angle up here is 40 degrees, what is angle, I call it angle X and angle Y. Yeah. Now remember, they all add up to 180. So if we do 180, oops, didn't want to do that, dot divide, not yet. 180, take away the 40 that we know about, that equals 140. So X and Y together make 140 degrees. They are the same as each other. So if I do 140 divided by 2, 70 degrees is X and 70 degrees is Y. And 70 and 70 and 40 make 180. Yeah. The other way on the isosceles triangle. There's an isosceles triangle. Maybe we've got, I don't know, 50, not drawn to scale. Yeah. So, X, Y, and Z. Yeah. Now, it will be much thinner than this. Yeah. So remember, all add up to 180. and x and y, x equals y. So therefore y will be the same as x, which equals 50 degrees. So now I can do x plus y, which is 50 plus 50, which equals 100 degrees. And when they all add up to 180, to find z, z equals 180, take away the ones we know about, which equals 80 degrees. Not quite to scale, but it doesn't matter. So yeah, an isosceles triangle. You can find the top bit, you can find the bottom bit, and be careful. Sometimes they're horrible in exam questions, and they turn it on its end just to make it like a bit more just awkward. Well, if they do that, just turn the exam paper round, rotate the exam paper. Right. So the other one we're interested in is this little chap here, and there. This is called a right angled triangle, because this is what we call a right angle. And remember that we've been doing that so far with a little curve. When it's a square, that means it's 90 degrees. So if we call that 40, yeah, you've got to know 2 to find, I wonder what this is, x. So remember, they still add to 180. So 90 plus 40 equals 130. So that's what we know about. All add up to 180. So 180 take away 130 equals 50 degrees, which is equal to x. So there you go, right angles. You've got to know 2 to find the third one, a right angle. Okay, so now we'll look at quadrilaterals. Yeah, four-sided shapes. So the first one is dead easy because this is a square. Now a square is made up of 4 right angles. Therefore, angles this time add to 360. Yeah, there's nothing to find out there in a square. Yeah, if you know it's a square, so it's always 90. And the same with a rectangle. Yeah, same with a rectangle, exactly the same. Everything is 90. Everything is 90. So 90, 90, 90, 90, add up to 360. Now, quadrilaterals only get a bit more interesting if we have one of these. And this is, I'm going to put a line there and a line there to say that this is called a parallelogram. And so that is the same distance as that, and that, I put 2 lines there, is the same distance as that. Now when you have 2 lines that are parallel to each other, we usually put like an arrow to tell us, regardless of the length, say these are the same lengths, and then we put these little dashes, but because they're parallel, we put little arrows on there. So we could redraw our parallelogram like this and go, that is parallel to that, and that one is parallel to that one. Now, again, all angles add to 360. But there's something about this parallelogram here, that this one is the same as that one, and this one is the same as that one. So the opposite angles are the same. Now, you can, with a parallelogram, you can with a parallelogram just be given, say that's 70 degrees. Yeah? We're going to do X, Y, and Z. You can find out all of them with the knowledge of that and this. So X will be equal to 70 degrees because it is the opposite angle to that one. Now, so well, I don't know what I'm going to call this, X, Y, Z. We'll just call it 70, yeah? So the 70 plus the 70, these two, total 140. So these opposite ones total 140. Now we know that all of them add up to 360. So if we do 360, I did that again, yeah. Take away 140, that leaves us 220 degrees. So it means that Y and Z together make 220 degrees. Y and Z are exactly the same as each other, therefore 220 divided by 2 equals 110 degrees, which equals Y, and it also equals Z as well. So let's have a look at, I don't know, let's have a look at some questions, see what they're going to give us, yeah? So here we go. Calculate the size of the missing angles in these triangles. So remember they all add up to 180. 60 and 40 make 100. So 180 minus the 100 we know about equals 80 degrees. 45, 65, all add up to 180. So that's 110. So 180 minus 110 is 70 degrees. So that one equals 70. The diagram on the right is a right-angled triangle. Calculate the size of angle A. Right, so we know that that's 90. So 90 plus 25 equals 115. So we know what these two are. All of them add up to 180. So 180 take away 115 equals 65 degrees. The diagram on the right is an isosceles triangle. Calculate the size of angle B. Now, if we take away what we know, we've got 180, take away the 20, which equals 160. So 160 is shared by these two angles there. So to calculate the size of angle B, because these are exactly the same as each other, we just need to go 160 divided by 2 equals 80 degrees. And the diagram on the right shows a triangle with a line of symmetry. That means that the left-hand side is a mirror image of the right-hand side. Calculate the size of angle C. Now, if this one is 40, then this one is 40 as well. So, 40 plus 40 equals 80. Everything adds up to 180. So if I take away 80, I'm left with 100. So this whole thing at the top is 100 degrees, but we only need half of it. So all we do is 100 divided by 2 equals 50 degrees. I think we've got some quadrilaterals here. Right, calculate the size of the missing angles in the quadrilateral. Remember, 360. So we've got 180, 260 with these three. So we need 360 minus 260, which equals 100 degrees. And this one's a bit more complicated. I'm going to use a calculator for this. 65 plus 75 plus 100, that's 240. So everything adds up to 240. So we do 360, take away 240, which equals 120 degrees. Josie has drawn the quadrilateral on the right. Brilliant. What's the size of the missing angle? Right, so there's the missing angle. So all adds up to 360. So we know three of them. So we've got 70 plus 90, which is the right angle, plus 160. So 70 plus 90 plus 160 is 320. And 360 minus 320 equals 40 degrees. The missing angle is 40. The diagram on the right shows a kite. Now a kite, see we've got a line of symmetry going through the middle there. So a kite, we've got everything adds up to 360. But the thing about a kite is these two are the same as each other. These two won't be, because that's like more pointy than that bit. But the left and right hand side of the kite, if I draw a kite that way, yeah, these two angles are the same as each other. So we've got 80 and 60 that we know about. So add those two together, gives us 140. So then we do 360 minus 140, which equals 220. So 220 is shared out between A and B. A and B are exactly the same. So 220 divided by 2 equals 110. So the angles A and the angles B are both 110. The diagram shows a parallelogram. It has two pairs of equal angles. It's even telling you, yeah? Calculate the size of A, B, and C. Well, B is the same as what we know, which is 100 degrees. So, oh, that's not A, is it? Yeah. So, B and that is 200. Yeah? B plus 100 is 200. So now we do 360, take away the 200, which is 160 degrees. So A and C, A plus C equals 160 degrees. Now A and C are the same as each other because they're opposite. So we just take the 160, divide by 2, which equals 80 degrees. 80 degrees. Quadrant angles in 3-sided shapes and 4-sided shapes. Good. All right. I'll see you in the next one, which is going to be, can't wait, median and mode.